Hey everybody, welcome to Office Hours, brought to you by Higher Learning Test Prep and RemoteTutors.com. My name is Jeremy Champa. We're going to talk about a few questions today. Two questions from the ACT actually, and one question from the SAT. And we'll actually start with that SAT question. But before we do, I just want to mention what we're doing here in case you don't know. So Office Hours is totally open to everybody. So if you have a question, doesn't matter if you're working with us or not, doesn't matter if you are a parent or a student or a college counselor, whatever it is, we're happy to have you here, and we're happy to have anybody ask questions. So if you have a question about the SAT or ACT, you can ask us live, or you can also just send us a message. You can get in touch on YouTube or on Skype, because we work a lot on Skype. You could also just email us or get in touch through the websites. Any way you like, higherlearningtestprep.com, remotetutors.com. So let's jump into this first question here. We're going to go through the Hangouts screen share vortex to our first question. And this is an interesting question. It's number 29 in the calculator section of a SAT. And this question, there's two ways of doing it. I'm going to show you first the sneaky way of doing it. This is the way I would do the question. And I'm drawing a Cartesian plane here. I think it's important to note that I never use the Cartesian plane for super precise stuff on the SAT, just for things that I can estimate or ballpark. So here's y equals 3. That's the first line that's given to us. And then we want to know what values of a and b to use so that we have exactly two real solutions. Here's what I want to mention. Use the answer choices to help you anytime you're confused, and even sometimes when you're just looking to move quickly. And what I'm noticing about the answer choices is that obviously 2 and 4 comes up a lot. There's only 1, 3 in all the answers. So that's important. And even more specifically, -2 is an a value in 2 of the 4 answer choices. And b equals 4 is a value for b in 2 of the answer choices. I'm going to start by just thinking about what answer choice b would indicate. Now, if a is -2, which is what this answer says, that means it's going to open down. And if b is 4, that means the y-intercept is 4. Okay, well, great. Actually, that's exactly what I need. Opening down, crossing twice. You'd probably still wonder what goes on with the other answer choices, so you might try them out. Answer choice A is going to start below the line y equals 3 at b equals 2, and it's going to open down. So that's going to have 0 solutions. Answer choice C, B is going to be 4, just like the right answer, except now A is +2, which means it opens up. So that's also going to have no solutions. It's never going to cross y equals 3 because it starts above and it stays above. Answer choice D certainly intersects once right at B equals 3, which of course is the y value for our line. But it opens up and it does so pretty steeply. Not that that matters. What matters is that it only hits once, and we want 2 solutions. So there's my answer, and I did that in really short order using an estimative approach. Notice this is the calculator section. I didn't need a calculator to do that. I just needed to understand what A and B do. Just to be clear, there is one other way of doing this question. It's just a little bit long-winded. I'm not going to do the whole thing, but I want to just mention you could use the component of the quadratic. The quadratic formula is -b plus or minus the square root of b squared minus 4ac all over 2a. The part under the radical, b squared minus 4ac, is called the discriminant. If it's positive, you get 2 solutions, which is what we want. If the discriminant b squared minus 4ac is 0, then you have 1 solution. So to be clear, answer choice B would have given you a positive discriminant. Answer choice D would give you, we know that we have 1 solution with answer choice D, even though we wanted 2. We can be pretty sure that the discriminant is going to work out to be 0 when we use answer choice D. And then lastly, if you have a negative value for b squared minus 4ac, that means you have no real solutions. No real number solutions because you'd have a negative square root. And I'll just mention why this question is difficult, because you might be wondering, like, well, why is this even hard if you could just do this basic thing? It's because when first of all, you would set these equations equal to each other. So 3 equals ax squared plus b. Then you have to get this in a standard form. So subtract the 3 ax squared plus b minus 3. Now, standard form is ax squared plus bx plus c, which is really close, except it's important to notice that this b is not the same as this b. Why? Because b is just a placeholder to say whatever the coefficient of x is. We don't even have a coefficient of x. So in our equation, a is a, but b minus 3 is your c value, which is hard. You have to plug those in up here. So for, this, it would be the square root of, we don't actually care about the square root, we just care about what's underneath there, but just for a placeholder, you can put it there. 0 squared minus 4 times a, which is, in this case, just a, and then c, which is b minus 3. Now you have to distribute the 4. Again, you don't really care about the square root, you just care is 0 squared minus 4a times b. I'm sorry, I wrote b minus c. It's b minus 3. My apologies. B minus 3 is your c value. So you'd have to do this math and figure out how to get a positive value using these b's and these a's and b's. So the bottom line is you have two variables. You're going to have to work with a and b anyways in some way, right? You're going to have to probably use these answer choices in some way. Why not just do it from the beginning with our estimative approach? If you want to know more about the discriminant approach, then I'd be happy to talk more about that in the next video. In the meantime, let's talk about the next question, which I think is an ACT math question. Yes, and it's in a similar location. The last one was number 29 out of 30 multiple choice questions in the SAT calculator section. This is 56 out of 60, and the reason I bring that up is because the questions get harder as they go. All right, so the first thing you should always do is use the answer choices to sort of frame your thinking. The fact that we have root 3s and root 2s should bring up the concept of 30, 60, 90s, which have root 3s in them. That would be like if you had a 30 and a 60 and a 90, the 30s across from the small side always, 60s across from the medium side, which is x root 3, and the long side is 2x. 45, 90s have root 2s in the side lengths. This is x, this is x, this is x root 2. So that's what you should be thinking about when you see this stuff. And in fact, if we think about what goes on here, this belt wraps 2/3 of the way around the large pulley. So if we kind of like drew off where it wraps around and where it doesn't, we would know that this is 2/3 of the way around. That means this is 1/3, which is like 120 degrees, right? And so I'm looking for 30, 60, 90s. I'm always just drawing lines on the figures to try to create special triangles, especially when I know there's 30, 60, 90s involved. So if this was 2/3, then this piece here is 1/3. I broke that in half by bisecting this angle. 1/3 of 360 is 120. So these are my 60-degree angles. These are 90s because that's important to know that if you have a line that hits a circle, where it hits the circle, you could draw a tangent line. Right? That's the definition of a tangent line. It's something that hits at 90 degrees, and that's always true from radius, from center of circle to edge, where a line goes off that edge. That's a 90-degree angle. Okay, so here's the deal. If you know that the radius is 5, then you know that the circumference of this circle is 10 pi. And you're going 2/3 of the way around the circle, so multiply that by 2/3, and you get 20 pi over 3. That's this distance. Now, check in with your answer choices. Obviously, these answers are starting to look really good, F and G, because they have something about pi and something about over 3. We're looking for the full belt length, which includes this little piece of this belt. And that's 1/3 of the way around the circle. That circle has a radius of 1. So to be clear, that radius of 1, the way you use that to get circumference, circumference equals 2 times pi times your radius of 1. Circumference equals 2 pi. And then 1/3 of that would mean 2 pi times 1/3. And that equals 2 pi over 3. Well, if you check back in with your answer choices, it looks like 22 pi over 3, which is the combination of the belt wrapping around the larger circle and the belt wrapping around the small circle makes a heck of a lot of sense. At this point, honestly, as a test taker, I would probably be picking G and moving on, because this has something to do with 30, 60, 90 triangles. There's one more step that might prove worth doing, but it's still going to get us in the same spot, which is, look, if you know that the radius is 5, go to your 30, 60, 90 triangles. If this is 5, then this length, this is the tricky part, from here, not to the edge of where we care about. We care about this distance because we're trying to find out what, this part and this part are doing. But the whole thing we actually know is 5 root 3 based on the proportion of sides of a 30, 60, 90. Right? Okay, well, 5 root 3 here, 5 root 3 over here. That gets you to 10 root 3. And look, it's not all the way home. I'll explain how to get all the way home. But at that point, 5 root 3, two groups of that, which is 10 root 3. Root 3 is not that tiny a number. Like, let's see, root 3, the square root of 3 times 10, that's much bigger than 10. So the idea that we're going to somehow get this all the way down to 8, that like more than half the distance has been removed in this little piece right here and here. We have 5 root 3, but that includes this extra piece on each side. It just doesn't seem likely. So, I would also say that the ACT is drawn to scale unless they say otherwise. So for all those reasons, I'd be picking G. The reason why G is right, I'm going to kind of draw a larger version here. This is what I'm drawing here is our small circle, right? So this is the extended piece. These pieces right here are like this guy and this guy. Those are each part of, you might say, another triangle. Draw the same kind of triangle. This is our mini circle right here. This is our radius of 1. This is a similar triangle. So these are 60s. That means this is 1 times root 3 because we know our ratio of sides of a 30, 60, 90. And these extra pieces of root 3 are how we get from 5 root 3 to 4 root 3, two groups of that, right? So 5 root 3 minus this piece, because we're wrapping around the circle here. We've already accounted for this wrapping around the circle with 2 pi over 3. That's where this came from. This piece here and here, these were extra pieces of our 30, 60, 90 triangle with side lengths of 5 and 5 root 3. We don't need these because we're not adding those. We're looking for where this belt wraps around, and the belt wraps around like this. It doesn't include this stuff. So we had 10 root 3s, but we're subtracting a root 3 from each of our side lengths. So these side lengths were actually the pieces that we cared about from here to here were 4 root 3. Okay, it's a super hard question, but what I want you to notice is you can go like halfway to the final answer and feel pretty confident that you're right. And that's really, really useful. Okay, so let's look at a grammar question from the ACT. And this question, I think it's important to note that there's very little difference between the grammar sections of these two exams. So this applies to both exams. This is the question we're looking at, number 48. And what I want to point out is equivalencies. That is, there is no functional difference on this test between a semicolon and a period. Everything in answer choices F and G are the same other than the period and the semicolon, and those are functionally the same. They can't be right because we can't be asked to choose between two answers that are functionally equivalent. So now we have two different ideas here. We have a comma or nothing at all. A lot of times, nothing at all is a totally good answer. Simple is good on this test. The problem is, I think, and I'm not totally sure here because I haven't looked closely at this yet, but therefore, comma, as long as even the smallest amount of carbon is present, comma, radiocarbon dating can date an artifact by calculating its ratio of carbon-14 to nitrogen-14. There's a comma here. And the reason why I'm going to go with H is because these two commas here and here work together. How do they work together? Well, this stuff in the middle, which adds to the sentence, is not absolutely vital for the meaning of the sentence. right? The sentence could be said, therefore radiocarbon dating can date an artifact by yada, yada, yada. Those two pieces go together. The middle piece isn't necessary. And even furthermore, you might say, well, why do I need a comma there? Well, if I don't have a comma at all, what I'm saying is that the sentence starts with this phrase. As long as even the smallest amount of radiocarbon is present, radiocarbon dating. It's just by plowing through that, what we've done is we've started the sentence with extra information instead of with the subject, right? So the subject is really radiocarbon dating. So when in doubt, think about how commas are working together, right? That's the difference between H and J is these commas work together to essentially create a parenthetical phrase, something that could be set off with parentheses from here to here. Okay, so that's a good one. And we're back through the vortex, back on the other side. I hope that these questions were helpful for all of you as you're studying for this exam. And I hope you'll feel allowed to ask any question you want about this test. Please get in touch. We'd be happy to help out no matter what your question is about the SAT or ACT, no matter who you are, no matter if you can pay for SAT help or not. In fact, almost more if I can't get you to work with us because, for financial reasons, I would love to provide some help. There's some things that good tutors can show you that you can't get in places like Khan Academy. And I love Khan Academy. I think it's great for so many things. I think it's a wonderful resource. But maybe next time I'll show you a question that kind of points out the difference between our approach here at Higher Learning Test Prep and at Remote Tutors compared to the way the College Board and Khan Academy would like you to do a question. I think it's important to see that difference. So look out for that next time. I think we'll be on at a similar hour tomorrow night. But either way, you can always watch the videos after the fact. And we hope you'll join us again. Until next time, see ya.